Today's video is going to cover solving for sides and angles with trig ratios. So we're going to get back into a little bit of review from geometry and learn how to find missing sides and angles of right triangles using these trigonometric ratios. This is Learning Target 2 in our unit on trigonometry. So there are some important names for the sides of triangles when they're right. If we are focusing our attention on this first triangle and focusing on angle A, we refer to the side across from angle A as opposite. The side that is directly next to angle A, which is AC, is referred to as adjacent. And of course, the side that is the longest side of a right triangle is always called the hypotenuse. Now let's focus our attention not on angle A, but on angle B. From angle B across from the angle is now our opposite side. Right next to angle B is called our adjacent side, and the longest side is always the hypotenuse. Notice that depending upon which angle we focus on, we refer to one side as opposite, or we might refer to that same side as adjacent. It really depends on which angle is the source of our problem. Sine is opposite over hypotenuse. Cosine is similar. It is adjacent over hypotenuse. And tangent is a combination of both sine and cosine. It is opposite over adjacent. Each of these circles with a little line through it is actually a Greek symbol for theta. And theta is our stand-in symbol for angles. So this would be the sine of an angle is equal to the opposite side divided by the hypotenuse side. And the cosine of an angle is equal to the adjacent side divided by hypotenuse. And the tangent of an angle is equal to the opposite side divided by the adjacent side. If you have trouble remembering what sine, cosine, and tangent are, remembering this acronym, SOHCAHTOA, is a good way of remembering what each of the ratios are. So, SOH, stands for sine opposite hypotenuse. CAH, C-A-H, stands for cosine adjacent hypotenuse. And TOA, T-O-A, stands for tangent opposite adjacent. This allows you to, through words, think about each of the different ratios for tangent, cosine, and sine. SOHCAHTOA. SOHCAHTOA. Let's get a little practice putting together these ratios using some sines, cosines, and tangents. Our source angle is angle B. Y would be our opposite side. I start abbreviating it as OPP. X is our adjacent side, and R is our hypotenuse. Sine is opposite over hypotenuse. This would be Y over R. Cosine is adjacent over hypotenuse, which is X over R. And tangent is opposite over adjacent, so that is Y over X. Remember, over is just another word for divided. We can also do this with actual values, which is what we'll mostly be doing in this class. This time we're looking at sine. Find my opposite first, then find my adjacent. And the longest side is always the hypotenuse. So my sine is 8 over 10, opposite over hypotenuse, which we can reduce down to 4 over 5. Cosine is 6 adjacent over hypotenuse, 10, which we can reduce down to 3 over 5. And our tangent, which is opposite, 8 over adjacent 6, which can be reduced down to 4 over 3. We can also find these ratios expressed as decimals by using our calculator. When we do this, you need to make sure that your calculator is set to degrees. When you get into class, if you're uncertain how to set any calculator, whether you use your smartphone or any other calculator, to degrees, ask me and I'll show you how. So the cosine of 46 is equal to 0.69, and this is rounded. The tangent of 120 is equal to negative 1.73. The sine of 35 is equal to 0.57. And the cosine of 265 is equal to negative 0.09. You could try typing these into your calculator to see if you get the same values that I get. Now it's time to start using our trig ratios to actually find the missing pieces, since now we know how to set up each of these ratios. For my x, I'm going to start off by using my 30. My 30 angle has an opposite side of x, and the other side that's given to me is my adjacent side. Opposite over adjacent is tangent. So to find x, I need to do the tangent of 30 degrees is equal to x over 15. Notice in the theta spot is my angle 30, opposite is x, adjacent is 15. To get rid of the 15, we times by 15 on both sides. And now I just need to use my calculator to do 15 times the tangent of 30 degrees. I get approximately 8.66. For sake of showing you some variety, instead of using the 30 on our next problem, let's use the 60. If I use the 60, now my opposite is the 15, and my y is my hypotenuse. So opposite over hypotenuse is sine. Let's use sine to figure out what y is. Which angle did I use? I use angle 60, so sine of 60. What's the opposite? 15 over the hypotenuse, y. In order to solve this, sine 60 equals 15 divided by y, I'm going to need to do two things. I'm going to need to multiply by y, so the y is no longer in the denominator. Y times sine 60 is now equal to 15. Since it says times sine 60, I'm going to need to divide by sine 60 on both sides. So my y will be equal to 15 divided by sine 60, which is approximately 7.32 rounded off. So you can see we can pick and choose between the two angles. Depending upon which angle I use, changes what is opposite and what is adjacent. But hypotenuse is always hypotenuse. Sometimes you get x on top, sometimes you get the variable on bottom. These are the two ways and the steps you would use to solve in each of those cases. There are situations, though, where you don't really get a choice. The problem is only giving you information to kind of force you to use one of the trig ratios. Since 48 is the angle that's given, the 6 is the adjacent side. It is right next to the 48. The x is the hypotenuse side. So since we are given only adjacent and hypotenuse for the 48, we have to use cosine, which is adjacent over hypotenuse. Which angle did I use to discover cosine? Angle 48. It's adjacent over hypotenuse, so 6 divided by x. Time to use those couple of steps. Times by x will get the x to go away. Don't forget the times by x on the other side. Rewrite our problem. X times the cosine of 48 is now equal to 6. it says times by cosine 48, so I'm going to divide by cosine 48. Divide it on both sides. Now the x is alone, and to find what it equals, I just need to do 6 divided by cosine 48. I get approximately 8.97. Let's do a little review. You don't have to write down the screen, but just think about it. When I ask you what is the inverse operation for each of these different operations, you'd probably say that the inverse of adding is subtracting, and the inverse of multiplying is dividing. Remember that the inverse of exponents like squaring is square rooting, so roots. But what is the inverse of doing sine? Well, there's an operation for that. The inverse, when we write it out and when you find it on a calculator, is written with this little -1. We've used this in other notations, such as our f of x notation, when we write f -1 of x. So we write it the same way when we do trigonometry. Usually in a calculator, you would type in sine and then the angle number. When you do the inverse, you do the opposite of that. Instead, you do sine inverse of the sides, opposite over hypotenuse. The reason why we use inverses is to find missing angles. And remember, theta is always our symbol for angle. Let's try typing these into our calculator. Do it along with me to see if you get the same thing. The inverse sine of 2 over 5 should give you a degree of approximately 223.58 degrees. The inverse tangent of 1 is exactly 45 degrees. And the inverse cosine of 2 is actually impossible. There is no possible way to get an inverse cosine of 2. You should get error. So you cannot actually do inverse sine, cosine, and tangent to absolutely anything. There are some exceptions. So let's try to find a missing angle. The angle I want to get is this angle right here. The 5 is my adjacent side. The 9 is my hypotenuse side. Opposite and hypotenuse, adjacent and hypotenuse is cosine. So in this problem, I have to use cosine. So I'm going to set this up similar to the way that we set up our problems in finding sides. The cosine of angle theta is equal to 5 over 9. To do this and get the theta, we use the inverse. So now it's going to say theta is equal to the inverse cosine of 5 over 9. Notice by moving the cosine to the other side, we now have the inverse. So let's do this in our calculator. The inverse cosine of 5 over 9 is equal to 56.3 degrees. Let's do this a couple more times if you want to see a little bit of variety. Angle theta in the first example has a adjacent side given to me as well as a opposite side. There is nothing on the hypotenuse. In this problem, I need to use tangent. So tangent of the theta angle gives me opposite over adjacent, 1 over square root 3. So let's find theta by doing the inverse tangent of those sides, 1 over square root 3. Type it into your calculator. Inverse tangent of 1 divided by the square root of 3. This gives me exactly 30 degrees. In this last example, theta has an opposite side of 4 and a hypotenuse of 11. Some students accidentally think that hypotenuse is sometimes adjacent because it does look kind of next to the angle. But remember, it's the longest side, and the longest side is special. So in this problem, opposite and hypotenuse means it's a sine problem. So the sine of theta is equal to opposite 4 over 11 hypotenuse. We'll get theta by inversing those sides, 4 over 11. So the inverse sine of 4 divided by 11 is approximately 21.3 degrees. That's how big the angle is actually. If you have any questions, make sure you send me a message or write them down in your notebook so that you can bring them in class and we can review. Don't forget to answer the questions after the notes and hit the big submit button at the end.